Exercise number 10. We are going to copy operations between setup locations associatively. All right. So we are going to review the manufacturing setup. We are going to open the part which is already open, and we are going to review the assembly structure and manufacturing setup. In the geometry view of the operation navigator, select the workpiece node. Okay, so we are in the manufacturing and the geometry view, right? And then we're going to select the workpiece node. NX highlights the part and blank geometry. The part and blank have been defined for each part component of the setup in separate workpiece objects. Okay, so this is the one we have to select, the workpiece. Right, select workpiece 1 node. Workpiece 1, where is it? Here. There. Select workpiece 2 node. Here. There. This scenario obviously is like a horizontal machine scenario, right? Where you have a tubestone and then you have maybe 2, 1, or 4 vices most of the time. Copy and paste the operations objective. Increase machining efficiency by copying operations and geometry objects from one workpiece to another. In the geometry view of the operation navigator under workpiece node, right-click MCS and choose copy. We're going to right-click. We're going to say copy. Okay, right-click workpiece 1 and choose paste inside with reference. Okay, we're gonna right-click and we're gonna say paste inside with reference. NX copies the toolpath operation parameters and operation geometry to workpiece 1 and maintains their associativity with the parent object in workpiece MCS1. The copied node is the child object. Got it? So this is a child object. Right-click workpiece 2 and choose paste inside with reference. Okay, we're going to right-click and we're going to select paste inside with reference. Expand workpiece 1 and MCS1 nodes as needed. The link icons in the path column indicate that the toolpath is linked to the toolpath of the parent. Okay, I'm gonna read that again. The linked icons in the path column, which is here. Okay, this is linked, 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 unlinked. indicate that the toolpath is linked to the toolpath of the parent, which is this one. This is the parent, these two are the childs. These two are dependents of this one. Under the workpiece node, select the mill control operation. Select the mill control operation. Notice that NX displays the nodes for the associative copies mill control 1 and mill control 2 in a lighter color font to indicate that they are dependent children of the mill control operation. Yes, I can see it. So when you select this one, you can see that these two are highlighted as well with a color or a light color. Right. Select any operation inside workpiece 1. Okay, I want to select this operation. NX displays a node for the parent operation under the workpiece node in red font when you select the dependent operation to indicate that it is the parent. I see. So when we select this one, we actually can see the parent up here. This is the parent. This is the child. All right. Review dependencies. Objective: use the dependencies column in the operation navigator to review the parent and dependent child relationship. In the dependencies column, if the dependencies column is not displayed, right-click the name column heading and choose columns dependencies. Okay, column. Configure columns. I don't see dependencies. I don't see dependencies. Can you see it? Dependencies here. In the dependencies column, you may want to move the dependencies column to the left by configuring the columns. Dependencies. Alright, let's go back. If the dependencies column is not displayed, right click the name column heading and choose column dependencies. Right click. There is no column, it's only column configurations. Column. Description. Folder. Column configuration, column configure columns, candidate columns, column configuration, don't see dependencies on this side, but I see dependencies here. So what's the deal? Hi? No. Something is not good. It says you may want to move the dependencies column to the left by configuring the columns. Oh yeah, but how? Please tell me how. Okay, dependencies are here and it's active, I just couldn't see it. Pause the cursor over the icons in the dependencies column. Notice the toolpad, the tooltips for the up and down icons. Okay. Other objects are dependent on this one. Okay. So how about if we go here? Right, so this one goes up because it's depending from another one that is up there somewhere. Same with this one. This one goes up and all this goes down, alright? Okie doke, edit a parent object and dependent object. Objective, edit a parent object and verify all dependent objects automatically update. Edit a dependent operation to reduce the step over and specify a different cut area. Under the workpiece node, double-click floor wall IPW tab to edit the operation. Double-click. In the floor wall IPW dialog box, set the following: cut pattern zigzag. Cut pattern zigzag. There. Click OK to save the operation. Wait a minute, we're gonna save the operation. We don't gonna generate. Let's see. Okay, notice that the parent and the dependent operations display a regenerate status. Yeah. Okay. I know what happened here. I accidentally deleted. Okay, so he's going to here, copy, and then copy inside with reference. All right. Under the workpiece 1 node, okay, we actually have to repeat this, that way we follow the way it's supposed to be. We say zigzag and then click OK. So we should have 1, 2, 3 operations that need regeneration. Now we're good, because before we only had 2, because I accidentally deleted this. So now we have 3, 1, 2, 3. So okay, we are good. Under the workpiece 1 node, double-click floor wall IPW tab 1. Verify that it now uses a zigzag cut pattern, and then click cancel. All right, so here. Yeah, this one is zigzag, and now we click cancel. Under the workpiece node, right click for wall IPW tab and choose generate. Generate. Notice that both the parent and dependent operations have been updated to display a repost status. Yep. 1, 2, 3. The 3 operations have been regenerated. All right, that's good. Under the workpiece 1 node, double-click floor wall IPW tab 1 to edit the operation. In the floor wall dialog box, set the following. So is this one? Right, let's expand this one a little bit. So floor wall IPW. Then we double click on it. In the floor wall dialog box, set the following: percent a flat diameter, 50%. Percent of flat diameter actually is 75, so we change it to 50. Enter. Click specify cut area floor, select the face shown. Click specify cut area floor here. Alright, in the cut area dialog box, click select the face shown, which is this face here. That face. In the cut area dialog box, click OK. Click OK to finish editing the operation. Notice that the tooltip in the dependencies column indicates that the toolpath is still linked to the parent. The tooltip notes the geometry and parameter edits you made to this operation. Okay, click OK to finish editing the operation. Click OK to finish editing the operation. Okay, here. Notice that the tooltip in the dependencies column indicates that the toolpath is still linked to the parent tooltip nodes. Notice that the tooltip in the dependencies column indicates that the toolpath is still linked to the parent. Yeah. The tooltip notes the geometry and parameter edits you made to the operation. Yeah, okay. This is right, this is information. The information is correct. It used to be 75, now it's 50. Good. Right click floor wall IPW top 1 and choose generate. The following message indicates that you are about to break the link of the copied toolpath. Click override path. In the path column, the generated icon indicates that the toolpath has been generated independently of the parent and is no longer linked to the parent. Really? And the path group, what is the path group? Here somewhere, right? Where is the path group? Freeze. Alright. I had to freeze one of them to make space. Path group. Alright. Path. Okay, path column. The tool path has been generated and is no longer linked. It's no longer linked to the one on the top here. That's something to be careful with. Alright, in the dependencies column, the icon indicates that the floor wall IPW tab 1 operation is still dependent on the floor wall IPW tab pattern and the workpiece. The tooltip notes the geometry and parameter edits you made to the operation. Okay, so we are going to column configure and freeze. Okay, let's see. Column configure. we're going to look for dependencies. Here, dependencies. This one here. And then we are going to move the tooltip. Holder, we're going to freeze. Channel, we're going to freeze. Tool, we're going to freeze. Tool description, freeze. Okay. Column configuration, tool description. We're going to leave this one on, we're going to leave this one on, we're going to turn off this one, we're going to turn off this, nodes, holder, tool number, time. But we want to leave time on, we want to leave length off, geometry, off, okay. Okay, we keep going with configuring. We wanna turn it off, 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 turn it off. Turn it off, 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 okay. Alright, we can see dependencies. So, what was the one we changed? The one we changed, it was this one, right? In the dependencies column, the icon indicates that the floor wall IPW operation is still dependent. So that means that if we move here, yeah, that is right. Still dependent on the floor wall IPW tab parent and the workpiece. The tooltip notes the geometry and parameter edits you made to the operation. Okay. Restore dependencies. Objective. Restore the dependency of the previous object by relinking the toolpaths, remapping the geometry and resetting parameters to the parent values. Under the workpiece 1 node, right-click for Wall IPW tab 1 and choose Dependencies Restore. NX displays the following message. So right here, and then we'll right-click, and then we say Dependencies Restore. NX displays the following message. This action will reinstate all dependencies to the source object or objects, including the toolpath. Do you want to continue? Click OK. There is no OK. There is yes. We're going to click on yes. NX does the following. Links the toolpath back to the parent. remaps the operation geometry to the parent, resets the parameters to those of the parent object, associates the parameters with the parent object, double click for wall IPW tab 1. Notice that the cut pattern has been restored to zigzag. The cut area contains just one face, and the percent of the flat diameter value is restored to 75%. Okay, this one is 75%, and then the area there is only one face. All right. Click cancel, place the cursor over the icon in the dependencies column, and notice that the tooltip reads dependent on other objects. The changes you made earlier to this operation are no longer listed. Dependencies dependent on other objects. Okay, that's good. And the changes that we made before are no longer listed. That's good. Update geometry mapping. Objective: remap geometry back to the parent without resetting operation parameters or linking toolpath back to the parent. You remap geometry when you edit geometry and parameters in a dependent operation, but later want to restore only the geometry back to that of the parent. Under the Workpiece 1 node, double-click Cavity Mill 1 to edit the operation. Double-click. In the Geometry node, in the Optional Geometry group, click Specify Cut Area. In the Geometry node, in the Optional Geometry group, what is the Optional Geometry group? And the Geometry node, in the Optional Geometry group, click Specified Area. Optional Geometry. What in the world is Optional Geometry? I don't see it. In the Geometry node, in the Optional Geometry group, click Specify Cut Area. It's maybe here. Select the face indicated to add. Select the face indicated to add. Okay, which is this one. Yeah, these instructions are not good. There. Click OK to close the cut area dialog box. Set the following parameters: cut pattern equals follow periphery, cut pattern equals follow periphery. Percent at flat diameter equals 25. 25. In the actions group, click generate. In the toolpath override message box, click override path. Click OK to complete the operation. You have edited the operation geometry by adding a face to the cut area, and you have edited some operation parameters. Now you will restore only the geometry back to that of the parent object without changing the operation parameters. Right click cavity mill 1 and choose dependencies, update geometry mapping. Dependencies, update geometry mapping. Double click cavity mill 1 to edit the operation. In the geometry node, in the optional geometry group, click specify cut area. We said it was here. Okay, let's see what it says there. Yeah, that information is not correct. So we just go here. We're going to expand this one. Come on. The cut area contains only the original two faces because it has been mapped back to the parent. In the cut area dialog box, click cancel. In the cavity mill dialog box, notice that the cut pattern parameters you specified earlier have not been changed. Okay. The follow periphery is still the same, and the 25% still the same. Generate the operation. Click OK to complete the operation. Close all parts without saving, and that's the end of this exercise.